Hello, let's continue solving part B. So, h of x and g of x function given to us depends on the f of x function. If you remember from the previous video, f of x function was f of x is equal to x square, and g of x function was x plus k square, and the h of x function was x square plus k, where k is non-zero real number. Okay, non-zero real number. So in part B, it says that explain graphical difference between g of x and h of x. So this is a kind of like transformation question. Uh, when we just move x squared towards left side or right side, or when you move x squared upward or downward, we will obtain either g of x or h of x. As you know, from the vertex form of the quadratic function, maybe I can name it with a different, just like since f of x, g of x we use already, we can name it, for example, uh, any just like function, f, g, h, okay, t of x, okay, t of x, for example, okay. T of x is like x minus h square plus k. As you remember, vertex of this function is h comma k, coordinate point. Okay, so this function, what is the role of h here and what is the role of k here? Normally, f of x is equal to x squared has a vertex of 0 and 0. And this vertex is shifted to point hk. So h is, we call it horizontal shift along the x-axis, okay? Horizontal shift along the x-axis. And the k is vertical shift. So when we have a vertical shift, as you know, vertical shifts along the y-axis, vertical shift along the y-axis up and down, horizontal shift right or left. Here in this question, when we add something in parentheses, this is becoming a horizontal shift. When we add something out of the parentheses, like this k, it's becoming a vertical shift. So what I mean by that, for example, let's give h of x an example since k is non-zero. If I say x squared plus 2, which means x squared graph shifted, x squared graph shifted 2 units upward, okay? 2 units upward. If it is x squared minus 2, which is 2 units downward, okay? So I will show it through Desmos calculator. G of x is another function. When I add this two, you remember from just classroom lessons also, this is a horizontal shift, means x squared function, x squared shifted. What do you think? Since plus it is, we should not mix with this. When it is plus in the vertical shift, it is going up, but when it is plus in the horizontal shift, it is not going right. So what makes this term is equal to 0, we need to consider. So x is equal to negative 2, we make this term is because of that, x squared is shifted 2 units left, okay? 2 units left. 2 units left. We should not confuse. When there is a horizontal shift, we should think about the reverse sign, okay? Reverse sign. When there is a vertical shift, no problem. We can think about the same sign. So graphically, these two functions, let me just highlight them. Graphically, this function and this function, they are different from each other. Okay, let me just show something on Desmos. As you see here, this is the graph of x squared, okay? This is the graph of x squared. So when I add something outside of x squared, you see it's a vertical shift, red graph came out. It goes 2 units up. So when I subtract something from x squared 2 units down, which is blue graph. Okay, so it means that adding something out of the x square or subtracting something out of the x square, shifting your graph up and down. Okay, so let me just make them invisible. If you add something inside the parentheses next to x, so that is, as I told you, horizontal shift. So plus 2 means your x square graph, green graph, will go 2 units left. As you see, as the purple graph is 2 units left, okay? The vertex became negative 2, 0. Actually, vertex was 0, 0 here, okay? When you subtract something, as I told you, it will go to 2 units right, okay? That is, black graph is here. So that green graph, which is x square graph, shifted 2 units right side. Since they are different from each other, so h of x and g of x function, they are different from each other. Whatever you get it, you need to write. If you have time, you need to write in this space provided. Okay, that's all. See you in the next video.